Alright, so we are going to look at products, and hopefully this video, after this live video has taken place, people go and rewatch the video as much as they possibly want to. Be doing corrections. So we look at products here. This is a grade 10 term 1 topic that is done. So as we get into this, guys, we're just going to do corrections of products for grade 10 term 1, the syllabus according to the South African CAPS syllabus. Welcome to everyone who's joined. You're more than welcome to share the link if you're in grade 10. Share it with everyone and anyone. Okay, so the first problem we are going to look at is x plus 5 into x plus 2. We look at the product of x plus 5 into x plus 2. And typically a question like this would say simplify, all right, or maybe to be more specific, expand and simplify. But whether the question says simplify or expand and simplify, generally we know that we are dealing with here two brackets, which means brackets means multiply. So it's a product of two binomials separately. So we remember something. First question we need to ask ourselves, one, how many terms do we have? It's very important that we establish how many terms we have. So because of the product of brackets, we know that this is one term. That's the first thing. Two, what method can then be applied for the product of two brackets? So here we know we can use FOIL. In other words, we're going to multiply the first terms, all right? FOIL using this DL, distributive law, and we apply S and L. Now FOIL means we multiply the first terms by distributing, meaning we are multiplying. We multiply the first terms first, then we multiply the outer terms, right? 2, then we multiply the inner terms using the distributive law, and then we multiply the last terms, all right? So this FOIL stands for multiplying the first terms. When we do that, we need to take into consideration our S, meaning our sign, then N, our number, and then L, our letter, when we are multiplying. So let's go. X times X, sign, number, letter. We know that X times X, the number before X and X is 1. So the 1 is they are both positive. So positive times a positive is positive, sign done. 1 times 1 is 1. And then the letter x times x is x to the power. When we are multiplying same bases, we keep the base. We have exponents 1 respectively for the bases x, so 1 plus 1 will obviously give us x to the power 2. Now this 1 that is a coefficient is always there, even if we do not write it down, okay? That's very important. So that's the first term, x squared. Then we take the outer terms, x times 2. So sign, number, letter, positive times a positive, positive. 1 times 2, because the coefficient of x is 1. 1 times 2 is 2. Then x, x. All right. We write the x as a product to the 2. And we combine the 2 and the x. Then we move on to the inner terms. Positive 5 times x, positive times positive, positive. 5 times 1, 5. And then the x, which is just a standalone letter, is combined with the 5. Then last but not least, positive times a positive, the last terms, positive times a positive is positive. 5 times 2 is 10. All right, and then there's no letter, so that's fine. Then, after we have done this, applied FOIL using the distributive law. DL means distributive law because we are distributing as we are basically employ the method of FOIL, and we apply what? A multiplication of the sign, multiplication of the number, multiplication of the letter. Then the third thing we need to consider is like terms. If they are like terms, we must add or subtract them, right? If they are unlike, we cannot add or subtract like unlike terms. So like terms can be added or subtracted Unlike terms, on the other hand, cannot. Unlike terms cannot. Now, how do we identify like terms? Like terms have the same variable and exponent. That's what's important about them. So we know that we have x squared plus 2x plus 5x plus 10. Now, which ones are like terms? It's positive 2x and 5x. So we can add these like terms and it will give us x squared. What's 2x plus 5x? It gives us 7x plus 10. So this here is our answer, x squared plus 7x plus 10. So all in all, what I'm saying to you guys is that whenever you do problems like this, the first question you need to ask yourself is how many terms do you have? Okay, so in this case, because of the brackets that are multiplied with each other, that means one term. So with a binomial times a binomial, we apply FOIL, meaning we multiply the first terms, multiply the outer terms, multiply the inner terms, and the last terms. Then we apply sign number letter as we multiply, meaning we multiply the signs first, multiply the numbers next, multiply the letters last. And we know when we multiply letters, remember if the bases are the same, we apply the law of exponents, we keep the base, we add the exponents. Then, if they are like terms, we add or subtract them. But remember, unlike terms cannot be added or subtracted. So in other words, x squared and 7x are not like terms. Even though there's x here, remember this x is raised to the power 2, whereas this x is raised to the power 1. So you cannot add these terms together because they are unlike. What makes terms unlike? It's when the variable and their exponents are not the same. Okay, it might be that the variables are the same, meaning the letters are the same, but if the exponents are different, then that makes them unlike. So we cannot add them together. So we leave our answer with x squared plus 7x plus 10, like that. Now I'm going to move a bit faster here now, because at least now you see what the method is for a binomial times a binomial. So here's another situation. We have another binomial times another binomial. So FOIL must be applied. So x times x, x squared. X times plus 2x is positive 2x. Minus 5 times x is negative 5x. Minus 5 times positive 2 is negative 10. Then I look and add what? Like terms. So x squared, what's 2x minus 5x? If you don't know what 2x minus 5x is, remember when you are adding like terms, you keep the variable and you add and subtract the numbers before the variable. So we have 2 minus 5. 2 minus 5, use your calculator if you need to, is negative 3. So the middle term is negative 3x, followed by negative 10. That's our answer. See? Number 3, x plus 1 into x squared plus 2x plus 3. Now this question, we ask ourselves the very same question. How many terms do we have? Because we have a binomial, but it's in bracket, and we have a trinomial, meaning 3 terms inside the bracket, and they're also in brackets. And we have 2 brackets multiplied to each other, which means how many terms do we have? We have 1. So we're going to use the distributive law, and basically after using the distributive law, applying S and L, meaning x needs to be distributed to x. After that's done, x needs to be then distributed to positive 2x. Then after that's done, x needs to be distributed to positive 3. When that's fully completely done, then we need to distribute positive 1 to x squared, positive 1 to 2x, positive 1 to positive 3. All the way as we apply the distributive law, we consider the sign, the number, the letter. All right. So basically this here, no different from this question, is that we are distributing each term to the term in the bracket, second bracket. So x times x squared, apply S and L. X times x squared. Positive times a positive is positive. 1 times 1 is 1. X times x squared, x to the power 1 plus 2. So remember, we keep the base when we are multiplying and we add the exponents. Then we take x, we multiply it by 2x. Positive times a positive, positive. 1 times 2 is 2. X times x, x to the power 1 plus 1. Move on to the next term. X times positive 3. Positive times a positive is positive. 1 times 3 is 3. X combined next to the 3. Right? So that means for the first term in the first bracket, we've been able to distribute it to all 3 terms in the bracket, and that's complete, finished, and done. Now we are going to take the second term in the first bracket, distribute it to all 3 terms whilst applying S and L. So positive times a positive, that is positive. 1 times, there's a 1 coefficient here, which we cannot see is 1. All right, we can write it down or not. Then x squared is the only variable. So we write it as x squared, which would be next to that coefficient 1. Then we take 1, we distribute it to positive 2x. So it's positive times positive is positive. 1 times 2 is 2. Then the x next to the 2. And lastly, positive 1 times positive 3 is positive. 1 times 3 is 3, and then there's no variable, so therefore that means these are our terms. Now we go ahead and we make sure that we've added the exponents nicely. We know we could have done that in one step if we wanted to, but for the sake of just making sure that you guys understand that there is an addition of exponents when we are multiplying same bases, I just did that step. But we know that some of you can go ahead and actually write this step immediately after this one, because the addition happens mentally in your minds. Okay, then we look at like terms. So after distributive law and applying S and L, we look for like terms which can be added. So x cubed is not a like term with anything, so it just is dropped as that. 2x squared and plus x squared are like terms. Okay, so these two, right? I'm just doing this because I want you to see the like terms. So plus 2 plus x squared. So x squared will obviously be there. But then plus 2 plus, remember the coefficient of x squared is 1. So what's 2 plus 1? Positive 2 plus 1 is positive 3. That's the coefficient of x squared. Done. 3x and plus 2x are also like terms. So we add the like terms, we keep the variable x, we add the coefficients, meaning the numbers before the variable. What's 3 plus 2? That's positive 5. So it's positive 5x. Then we have a constant term that is all alone. So we also bring it down, and that's plus 3. Can we move on any further from here? Definitely not. Why? Because x cubed and x squared and x are unlike terms. Why? Even though the variables x are the same for different terms, but the exponents are different. Therefore, these are unlike terms. We cannot add or subtract unlike terms, so we leave our answer simplified in this state with 4 terms in it. Make sense? Let's move on to number 4. 2x plus 4 into x squared minus 3x plus 1. How many terms in this particular expression? It's also 1 term. Why? Because brackets multiplied by other brackets means 1 term. So what do we do here? We use the distributive law. What do we mean by distributive law? 2x will be distributed to x squared, 2x will be distributed to minus 3x, 2x will be distributed to positive 1 using multiplication. But when we multiply, what do we need to consider? We need to consider the multiplication of the sign, multiplication of the number, multiplication of the letter. We always need to consider these. So let's go. What's 2x times x squared? So once again, we multiply the positive times the positive, which gives us a positive number. We multiply the number. 2 times coefficient of x squared is 1. What's 2 times 1? It's 2. We multiply the letter. X times x squared is x. We know the exponent here is 1, so it's 1 plus 2. We add the exponents. Move on to the next term. 2x times minus 3x. Positive times a negative, negative. 2 times 3, 6. X times x, x to the power 1 plus 1. Remember the exponents there are 1 and 1. Move on to the next. 2x distributed to positive 1. Positive times a positive, positive. 2 times 1, 2. X, we write it as x next to the 2. All right? This S and L is going to get in the way. Then we take this term, 4 times x squared. We take 4 times negative 3x. We take 4 times positive 1. So what's positive times a positive? It's positive. Now let me just move this S and L. People, I'm sure you understand what I said there. 4 times 1 is 4. And then x squared next to 4 times negative 3x. What's positive times a negative? It's negative. What's 4 times 3? That's 12. X next door. Then what's positive times a positive for the last term? Positive times a positive is positive. 4 times 1 is 4. There is no variable, so obviously no variable will be included. Next step, we have 2x. What's 1 plus 2? It's 3. Minus 6x. What's 1 plus 1? It's 2. Plus 2x plus 4x squared minus 12x plus 4. All right, these are our terms. Now we identify the like terms. So let's go. 2x cubed. We have negative 6x squared and plus 4x. Those are like terms. So whenever we are adding like terms, we keep the variable exponent, which is x squared, and we add the coefficients. So what's negative 6 plus 4? That is negative 2. Then we move on. What's this? Plus 2x and minus 12 are also like terms. So that means we keep the variable, obviously x, and then we add the coefficients. What's 2 minus 12? It's negative 10x. And then last but not least, the constant, which is alone. So here, 2x cubed minus 2x squared minus 10x plus 4, these are unlike terms. Can we add or subtract them? Definitely not. So therefore, we leave our answer in this state. Right? Okay. Now, next question. Number 5. 3x minus y into 2x squared plus 4xy minus y squared. Okay. 3x minus y into 2x squared plus 4xy minus y squared. So let's go. 3x times 2x squared. Once again, we distribute because how many terms in the expression? We have two brackets that are multiplied, joined together by brackets. So that means this is one term. Then we are going to distribute 3x to 2x squared, 3x to 4xy, 3x to minus y squared. Then we're going to take negative y distributed to 2x, negative y distributed to 4xy, negative y distributed to negative y squared. So let's go. What's 3x times 2x squared? Remember, we distribute using S and L. Sign, number, letter. Positive times a positive, positive. 3 times 2, 6. X times x squared. By now, in your head, mentally, you should be seeing that 1 plus 2. So you should be able to write x to the power 3 easily, all right, because we add the exponents. Then we take 3x times 4xy. Positive times a positive, positive. 3 times 4, 12. X times x, remember that's x to the power 1 plus 1, which is x squared. Then there's a y as well. So the y is solitary, so it is combined with the entire term. 12x squared y. 3x times negative y squared. Positive times a negative, negative. 3 times 1, 3. X times y squared, x y squared. Okay. Done with the distributing the first term to all three terms inside the second bracket. Now we take negative y. Negative y times 2x squared. Negative times a positive, negative. 1 times 2, that's 2. y times x squared. So in alphabetical order, we are going to write x squared y. Why? Because you know what? The order of the letters doesn't matter, but I write it in alphabetical order because you can see x starts, y follows, x starts, y follows. So I'm just trying to be consistent so that my mind's eye can just remember the similarity. So I write in alphabetical order, all right? Doesn't really matter what order that you write because multiplication, we say, is commutative. When I say multiplication is commutative, it means that the order in which you write numbers when you multiply doesn't matter because it still gives you the same answer. So we write negative 2x squared y for this term, right? Then we say negative y times positive 4y. What's negative times a positive? It's negative. What's 1 times 4? It's 4. What's y times xy? So obviously we have x, all right? And then the y is basically having a y times y. So we keep the base y and we add the exponents for y. So that's 1 plus 1, which is y squared. Okay. Then last but not least, what's negative y times negative y squared? Negative times a negative is positive. Then 1 times 1 is 1, obviously. Then y to the power 1 times y to the power 2 gives me y to the power 1 plus 2, which gives me y to the power 3. So those are my terms, guys. All right. And I've multiplied correctly. So now it's up to me to move on to the next step. After distribution and multiplying using SNL, I now have to check for like terms. So 6x cubed is a single term that's different from every other. 12x squared y, which is positive, and negative 2x squared via like terms. So what do? We keep the variable x squared y, and then we add the coefficient. What's 12 minus 2? 12 minus 2 is plus 10. I know some people will insist on bringing the terms close to each other in the next step, which is fine, so that you can see the like terms. But I mean, we can just move in this fashion as well. That's fine, okay? And remember, this circling is just for me to be able to identify the likeness. So negative 3xy squared is like negative 4xy squared because of the variables and the exponents being the same. It's like they're wearing the same jersey, if you will, you know. So negative 3 minus 4 is, we keep obviously the variable exponent, and what do we do to the coefficients? Negative 3 minus 4, if you take your calculator and say minus 3, negative 4 will give you negative 7. And then lastly, the last term is y cubed, which is unlike any other term. So our final answer is exactly 6x cubed plus 10x squared y minus 7xy squared plus y to the power 3. Right? So that was pretty much straightforward, straight to the point. Okay, and these basically the last, this 3, 4, 5 are your typical binomial times a trinomial. Okay, binomial times a trinomial, that's basically multiplication of a single expression. And then the first two that I had done are a typical binomial times a binomial, all right? And pretty much we are applying the same systematic rule. Then the very last question, where binomial times a trinomial is concerned, for at least, sorry, not the second last, let me say, yeah, the second last question, where binomial times a trinomial is concerned, because I want to look at another type here. So x minus 1 into x squared minus 2x plus 3. Let's look at this one. So we're going to distribute each term, obviously, as we said, using the distributive law, we multiply. So we apply SNL as we do so. X times x squared, positive 1 times positive times a positive is positive, 1 times 1 is 1, x times x squared is x to the power, the exponent 1 plus the 2 gives us x to the power 3. Okay, then x times negative 2x, positive times a negative is negative, 1 times 2 is 2, x times x is x to the power 1 plus 1, the exponent gives us x to the power 2. Then x times 3, Positive times a positive is positive. 1 times 3 is 3. And then the x combined with the 3. Then negative 1 times x squared. What's negative times a positive? Negative. 1 times 1 is 1. And then x squared, because that's the only variable. Then we distribute negative 1 to negative 2x. What's negative times a negative? Positive. 1 times 2, that's 2x, x. Then last, negative 1 times positive 3. Negative times a positive is negative. 1 times 2 is 2. And that's pretty much the last term. Then we finally wrap it up. We look at like terms. We can see that negative 2x squared has this like term, that's negative x squared. So we know x cubed has no like term. Negative 2x squared minus x squared. We keep the variable and its exponent. And what do we do to the coefficients? Minus 2 minus 1 gives you negative 3. Okay. Then we have plus 3x and plus 2x, which are also like terms. So we keep the variable as it is. We add the coefficient. What's 3 plus 2? Plus 5. And then the constant minus 2 is a standalone. Can we go on any further from here? Definitely not. We leave our answer in this state. All right. And this basically, we cannot add these terms together, because x cubed, even though the bases x, x, x are all the same, but because these are different terms separated by a plus and a minus signs, these are 4 separate terms, you cannot add these together because they are unlike terms. The variables together with their respective exponents. The exponents are different for the same variable, so we cannot do anything. Okay. Let's look at a question slightly different here. 9x squared plus 12xy plus 16y squared. We're still in the ballpark of the same questions that we were doing, but look at this. Okay, so first things first, look at this question. This question is also a trinomial in brackets times a binomial in brackets. So how many terms basically in the whole expression? It's 1 term, because brackets combine terms. So we have another binomial by a trinomial, but it's just that the trinomial is first and the binomial is second. What do we know about multiplication? Multiplication is commutative, so the order doesn't really matter. We are still distributing, all right, this to all terms. So what we can do, for the sake of our head, we can just write the order so that it satisfies and appeases what we already know in our heads. So let's start with the binomial and then follow it with the trinomial. Does it change anything as far as the expression is concerned? It doesn't, guys. It's still the same expression. It's just that what we've done is that because we know multiplication, a times b is the same thing as b times a, because we know that multiplication is commutative, we can go ahead and actually rearrange the order in the way that we know. Then we know what we ought to do. We apply the distributive law the way that we know, using S and L. So let's go. Positive times a positive is positive. 3 times 9, 27. X times x squared. We keep the base. We know there's an exponent 1. 1 plus 2 is to the power 3. We take 3x, we multiply by positive 12. Positive times a positive. Positive. 3 times 12, 36. X times xy. Bases are the same. You keep the base for same bases. X to the power 1. Remember there's a 1 there as well. So it's 1 plus 1, which is x squared. Then followed by y. Okay. We take 3x, we distribute to positive 16y. What's positive times a positive? Positive. What's 3 times 16? 3 times 16 is 48. Okay, if you don't know it off by heart, you can utilize your calculator. And then it's x combined with y squared. All right? Yeah, because multiplication combines variables. Then we take minus 4y, we distribute to all 3 terms. Negative times a positive, negative 4 times 9, 36. Y times x squared, alphabetical order, x squared y. Even if you said y, x squared, it's still the same thing. But remember, I'm just doing it for the sake of making sure I have alphabetical order for all terms where the variables are combined. Then negative 4 times positive 12. Negative times a positive, negative. 4 times 12, 48. Right? Then y times xy. Y times xy. X is alone, so we write it as x. And then y. Keep the base for same bases and add the exponent. We have exponent 1 here, we have exponent 1 here, so it's y to the power 1 plus 1, which is y squared. Then lastly, what's negative 4y times positive 16? So negative times a positive, negative. Then we have 16 times 4. What's 16 times 4? That is 64. And then last but not least, y to the power 1 times y squared gives us y to the power 1 plus 2 in the exponent, which is y to the power 3. So we just do the mental addition in our heads. Then, like terms, 27x cubed is solitary, alone, single, plus 36x squared y minus 36x squared y. These guys are like terms. Now you take your calculator, so x squared y, when you are adding like terms, you know that it would be x squared y, right? The variable would be placed, but what's 36 minus 36, guys? 36 minus 36 gives you 0. So you can literally write down the 0x squared y. Okay, and I just want to get to a point here. Okay, so just entertain me for a moment. Plus 48xy squared is the same like term as negative 48xy squared. Remember, why are they like terms? It's because the variable x, there's x, y squared. That makes them like terms. So what we do, we keep the variable xy squared, and then what do we do to the coefficients? 48 minus 48. We use our calculator. 48 minus 48 gives us 0 xy squared. And then our last term is unlike any other, so we write it as negative 64y cubed. Now people, please take note. The final answer is 27x cubed. But here's this thing. 0x squared and y have a relationship of multiply. So what's 0 times x squared? It's 0. Anything multiplied by 0, guys, is 0. So we are left with 0 here. And what about this term? 0 times xy squared, that's also 0. So that means we have 0 here. So therefore, all of this falls away. What are we left with? 27x cubed minus 64y cubed. This would be our final answer. All right. So hopefully this kind of makes a bit more sense, because maybe someone else here wouldn't have written this down. But I just wrote it down because I needed you guys to see why it is that we have nothing now in between the 27x cubed and the negative 64y cubed. 36 minus 36 is not 1, guys. 36 minus 36 is 0, which means basically this something minus that particular thing gives you 0. We could have also just chosen not to write anything in between here. We could have chosen to just write the final answer after this step and write 27x cubed minus 64y cubed as our final answer. So what I'm saying is, it's not really necessary to do this, but I'm showing it to you so that you can appreciate why it is that we have nothing in between 27x cubed and 64y cubed. All right. So this was just another problem with distributive law was concerned. Okay, so we've looked at 2 types of questions so far. We've looked at when we have a product of a binomial times another binomial, and then we've looked at a situation where we have a product of a binomial and a trinomial, whether that order is starting with a binomial followed by a trinomial, or sometimes when the order is actually a trinomial followed by a binomial, where we can first rearrange it because multiplication is commutative, and then we apply the distributive law using sign, number, letter, and then we simplify. So hopefully, as you've been listening to me rehearse this, right, and even as you will be rewatching the video when you have the time, you can actually master this particular segment of the work. Very important segment to actually master. Now let's move on now and look at another type of question. still under one term, multiplication of one term. So let's look at this one. 5a minus 2b to the power 3. Now, this question here, very, very important. This here is a binomial inside the bracket, but it's raised to the power 3. What does this 3 suggest, the exponent 3? It suggests that we need to do this. We need to open 3 brackets of what? Of 5a minus 2b. That's the first step. So 5a minus 2b, we need to acknowledge that inside this bracket there are 2 terms. What does this to the power 3 suggest? It suggests that open 3. Because of this 3, we have to open 3 brackets of 5a minus 2b. This is what this here means. This 5a minus 2b to the power 3 means open 3 brackets on that. 5a minus 2b into 5a minus 2b into 5a minus 2b. Now, a method that you can then use to make life very easy for yourself. Keep the first bracket. Please, keep the first bracket. Multiply the last 2. You hear what I'm saying? Method I will suggest is 1. Keep the first bracket. What does it mean if I'm saying keep the first bracket? Keep it as it is. So I've just done that. And what am I saying? Multiply the last 2. So we are going to take these last 2 and apply FOIL. Are you with me? All right. So that we can make our simplification life easy. This is the suggested method, and I repeat, this is the suggested method. So we keep the first bracket as a binomial bracket as it is, and then we multiply the last 2 brackets. Please, guys, multiply the last 2 brackets, and there we are going to apply what? Apply FOIL for the last 2. All right. So let's go. This is just a suggested method. So 5a times 5a, sign number letter, 25a squared. I'm sure you get the drill. Positive times positive, positive. 5 times 5, 25. A times a, we keep the base a, we add the exponents a squared. 5a times negative 2b. Sign number letter. Negative, positive times negative, negative. 5 times 2, 10. A times b, a. Then negative 2b times 5a. Negative times a positive, negative. 2, 5, 10. B times a in order a, b, alphabetical order. Then lastly, negative 2b times negative 2b, positive. 2 times 2, 4. B times b, we keep the base, we add the exponent, so we have b squared. Then in that second bracket, we make sure that we take care of the like terms. So if 25a squared minus 10 minus 10, please guys, ab stays the same as the variable, but minus 10 minus 10. If you're not sure, please don't say 0. Take your calculator and punch it in. Negative 10 is negative 20, people. Please, please, please. We cannot make mistakes with addition of like terms. We did addition of like terms in grade 8. We did addition and subtraction of like terms in grade 9. At this point in grade 10, you should be a pro at adding like terms. If you feel you are at loss, use your calculator. Plus 4b squared. Now, by doing this, what have we created? We've created a binomial multiplied by a trinomial. Do you see what we've done? By doing this, by making sure that we keep the first bracket and we multiply the last 2 brackets, we've created a binomial by a trinomial. So now we know almost how we take care of a binomial by a trinomial. We apply now the distributive law using S and L. Distributive law means the following. We take 5a, the first term, we distribute it to all 3 terms. Then we take negative 2b, we distribute it to all 3 terms by multiplication. And S and L, what does it mean? It simply means we consider as we distribute the sign, the number, the letter. Okay, let's go. Positive times a positive, positive. 5 times 25, 125. A times a squared, a to the power 1 plus 2, which is a to the power 3. Okay, next one. 5 times negative 2. Positive times a negative, negative. 5 times 20, 100. A times AB. A is a to the power 1 plus 1, which means a squared, and then the b follows that. Next term, 5a times 4b squared. That gives us plus 20ab squared. All right, I think I'm going to run out of space because I have that. I'm just going to scratch that, guys, so please forgive me for that. Then we take negative 2b, we multiply with 25a squared. Negative times a positive, negative. 2 times 25, 50. B times a squared, alphabetical order, a squared b. We take negative 2, we multiply by negative 20ab, negative times a negative, positive. 2 times 20, right, that's 40, and then b times ab squared. So that's a b squared. That's a, then b times b, b to the power 1 plus 1, which is b squared. Then last but not least, what's negative 2b times plus 4b? Negative times a positive, negative. 2 times 4, 8. B times b squared, b to the power 3. So I'm just going to rewrite these terms properly so that you can see all of them. So I had 125a cubed minus 100a squared b plus 20ab squared minus 50a squared b plus 40ab squared minus 8b cubed. All right, so that's beautiful, eh? So you see how easy it is that whenever you have a binomial raised to the power 3, what you can do is you can keep the first bracket and then you can multiply the last two. And then when you do that, you create a binomial by a trinomial situation, which you know how to take care of. So it makes life very easy. Then we know that we can now identify like terms. So 125a cubed, all right, is fine. It has no unlike term. 100a squared b has a like term with minus 50a squared b. That gives us a minus 150a squared b. Plus 20ab squared is a like term with plus 40ab squared. The variable is ab squared. When we add 20 and 40, we get 60. Then lastly, this term minus 8b cubed, which is a standalone term. Yeah, guys, I hope you can feel the fire there. That was nice. That was a very nice question. Okay, at least when we have established a method, then we are fine. Okay, yeah, so remember, what did I say about this binomial times binomial the whole to the power 3? You open, it means open 3 brackets of 5a minus 2b, which we did. You keep the first bracket, you FOIL, or you multiply out the last 2. That's what you do. That helps you to establish a binomial by a trinomial, which you know how to actually solve because you take the binomial, you distribute, right? And then you get your terms, you add and subtract your like terms, and then you write your answer and you leave it when there's no longer any like terms, because a squared b is not the same thing as ab squared, so there's no addition that can take place from this point. You leave these terms as they are. Okay, right, let's move on to the next question that we can look at that has to do with a single term. X squared plus 1 into x to the power 4 plus 1 into x squared minus 1. Now guys, here we have 3 binomial brackets. So we can choose to basically use the approach that we have just looked at, where we keep the first term bracket and then we multiply the last two. All right. Now, some people who will see that maybe there's another easier way of doing it will see that x squared and x squared plus 1 and minus 1 are actually two brackets that sort of like impose a situation where we have a positive 1 and a negative 1, but these are the same. So some people would rearrange the brackets and write x squared plus 1 followed by x squared minus 1, right? And then they would multiply those out because multiplication is commutative, remember, so it doesn't really matter the order. So it's really up to you how you choose to do this. At the end of the day, you'll still get the same answer because the order of whichever bracket starts first doesn't really matter. So what we're going to do, we're going to keep the first bracket and multiply the last two, just for the sake of what we've just learned. So we keep x squared plus 1 as it is, all right? Maybe someone else will do it differently, but you'll arrive at the same answer, guys. And then we multiply out the last two by FOIL. So what's x to the power 4 times x to the power 2? That gives us x to the power 4 plus 2, which is 6, right? We still keep the bracket because in this situation, we remove the situation of having two brackets to just one when we FOIL, all right? And this is very important. But because this bracket is still multiplied to all of what we have here, we still maintain the bracket for the two terms that we are multiplying. So let's go. X to the power 6. X to the power 4 times negative 1 gives us negative x to the power 4. Positive 1 times x squared gives us plus x squared. And then positive 1 times negative 1 gives us negative 1. Now we have a binomial by a 4 terms, which is fine. So we can distribute x squared to all 4 terms. That's what we can do first. So x squared times x to the power 6 gives us x to the power. Remember, we keep the base, we add the exponents. What's 2 plus 6? 8. X times negative 4. Positive times a negative, negative. 1 times 1 is 1. X to the power 2 times x to the power 4. We keep the base, we add the exponent. That's 2 plus 4, 6. X squared times x squared. Positive times a positive is positive. 1 times 1 is 1. X squared times x squared. Keep the base x, we add the exponents. 2 plus 2 is 4. X squared times negative 1 is negative x squared. Then we take positive 1, we do the same distribution. Anything multiplied by 1 is actually there. So what's 1 times x to the power 6? It's x to the power 6, that's positive. 1 times negative x to the power 4 is negative x to the power 4. 1 times x squared is positive x squared. 1 times negative 1 is negative 1. Okay. Then what we do now is we are going to go ahead and subtract the like terms. X to the power 8 is solitary, it has no like term. Negative x to the power 6 has a like term. Negative x to the power 6 plus x to the power 6 gives us 0. So let's just write the 0. Or we can choose to write nothing. X to the power 4 minus x to the power 4 is also 0. Negative x squared plus x squared is also 0. Negative 1 is the only constant term that's there, so our final answer is x to the power 8 minus 1. Remember, guys, if I wanted to, I could have said 0x to the power 6, 0x to the power 4, and 0x to the power 2, and then obviously gotten the answer. Remember, it's still the same thing relatively, so final answer is x to the power 8 minus 1. Okay, so those are one-term type questions where we have products, okay? One term where brackets combine the terms, and so forth and so forth. So let's look at another question where there's one term, but just slightly with a different spin to things. 2x to the power 4, 3x to the power 4 to the power 3 over 2x to the power 4 with a dot, 3x to the power 4 raised to the power 2. So what's beautiful here is that we need to first look at the question. How many terms do we have for the entire thing? We have one term. Remember, when we have a line, a division line, that suggests that this is one term. Then let's look at the respective numerator and the denominator so that we can actually make beautiful conclusions that will make life easy for us. So if we look at the numerator inside the bracket, how many terms do we have inside the bracket? We have 2 terms. All right. Now look at these 2 terms. What are these 2 terms actually? These 2 terms inside the bracket are actually like terms. Right? Someone would be tempted to want to open 3 brackets because, yes, there are 2 terms inside the bracket raised to the power 3. This does suggest open 3 brackets of 2x to the power 4 plus 3x to the power 4. We could do that, but what we notice is that inside this bracket, okay, and this tends to be maybe a little bit more complex question where you need to apply, certain processes. So 2x to the power 4 plus 2x to the 3x to the power 4, these are like terms. So we can add like terms. If they are there, let's add them. So if we look at the numerator, what's 2x to the power 4 plus 3x to the power 4? Keep the base, x to the power 4, we add the coefficient. What's 2 plus 3? 5. Now we're raising that to the power 3. Does that make sense? We can do that because we have like terms inside this bracket. Okay, let's move on. Let's look at the denominator before we do anything further. Look at the denominator. 2x to the power 4 dot. What does this dot stand for in mathematics? It means multiply. That's what it means. So what's 2x to the power 4 times 3x to the power 4? When we multiply using S and L. So this is a positive 2 times a positive 3. That gives us 6. Then this is x to the power 4 times x to the power 4. So we keep the base, we add the exponent. So this is x to the power 8, and it's raised to the power 2. Okay, so if you ask me, in the numerator, we were able to establish something. In the denominator, we were able to establish something, and we used what we already know from previous grades to actually go and establish that. Do you see? So that's why 2x to the power 4 plus 3x to the power 4, we know these are like terms, so that gives us 5x to the power 4. In the denominator, 2x to the power 4 times 3x to the power 4, that basically is us applying our multiplication and our understanding of multiplication. These we can multiply these two. 2x to the power 4 times 3x to the power 4, multiply using sign number letter. So we get 6x to the power 8. Now when we simplify further, in the numerator, we can apply the law of exponents. Right? There's that law of exponents that says a to the power m, b to the power m raised to the power n is actually equal to a to the power m times n, b to the power m times n. Right? You take the exponent on the outside, you multiply it with each base's exponent. So how many bases do we have inside this bracket? We have 5 and x. So we're going to say 5 to the power 1 times 3. Remember, there's a 1 there. 1 times 3, x to the power 4 times 3. Over, we do the same thing in the denominator. 6 to the power 1 times 2. X to the power 8 times 2. Does that make sense, guys? I hope you guys are clear. It makes sense because we are applying this law of exponents that we learned in previous grades. All right, in grade 9, we learned this law. About that when an exponent, a base is raised to a certain exponent times another base, a different base raised to another exponent, we can basically distribute this exponent that's on the outside by multiplication to each respective exponent for each base inside the bracket. That base, whether it's a number or a variable, we distribute that exponent. So this is the exponent 3. We distribute that exponent by multiplication to each exponent for each base, right? So then we get what? What's 5 to the power 3? 5 to the power 1 times 3, it's 5 to the power 3. X to the power 4 times 3, that's x to the power 12 over 6 to the power 1 times 2, which is 6 to the power 2. X to the power 8 times 2, that's 16. This is 125 over 36 for the numbers. As for the letters, we have x to the power 12 minus 16. When we get here, the relationship between the numerical bases and the variables is one of multiplication and division. Where there's multiplication and division, we can we can easily apply when there's multiplication and division, right? We can easily apply law number 1 and 2 of exponents, right? So these are same bases. We are dividing same bases. There's that law that says a to the power m divided by a to the power n. If we are dividing same bases, what we do to the exponents, we subtract the exponents. This is the same thing as a to the power m divided by a to the power n. We keep the base, we subtract the exponent. So we're doing the same thing here, all right? This exponent moves to the numerator, changes to negative 16. So basically we get an answer of 125 over 36. In the numerator, we get x to the power 12 minus 16. It's x to the power negative 4. But we know we cannot leave our answer as a negative exponent. So what we do is we use the negative law of exponents. And we write this x to the power negative 4, not in the numerator anymore, but in the denominator, but with a changed sign to the exponent in the denominator, which is x to the power 4. Where does that come from? It comes from the definition of laws of exponent. A to the power negative 1 can be written as 1 over a. All right? Yeah. This is actually really in the numerator. It's got a negative exponent. When you write it as a positive exponent, you displace the a to the power negative 1 to the denominator, and then you write it as a positive a to the power 1, as long as there's a relationship of multiply and divide only. All right, that's where this thing applies. So that is our answer. Okay. Now let's move on to products when there's separate terms. Look at this one. I want us to look at this particular problem. First question we ask, how many terms do we have in the expression? Do we know? How many terms do we have in the expression? So how many terms? We have one term, then there's a minus sign which separates, then we have the second term. So these are separate terms, okay? Now, that means we can FOIL this bracket then, because it's one term. We can deal with it. But the minus 2x is a standalone term. It is not in any way affected or wants to do anything with this term, because it's a separate term. It's alone. It's separated by the minus sign. Minus and plus separate terms. So how many terms is where we start? How many terms? We've established it's 2 terms. Then how many? Let's look at these terms. This is the first term. This is the other term. So then here, with this first term, we can FOIL. 2x times 3x, 6x squared. By now, you guys should know the rule that we multiply now signs, we multiply numbers, multiply letter. So it's 6x squared minus 12x plus 3x minus 4. Right? That's done. Then it's followed by minus 2x. By distributing FOIL, we've removed the bracket here. Okay, the bracket is removed because this here does not have a relationship of multiplication with this one. We remove it if it's a separate term, but we wouldn't have removed it if this here had a relationship of multiplication with negative 2x. But since it doesn't, we remove the bracket. Does that make sense? Then now all we are left with to do. So what did we do here? We FOILed term 1. Okay, distributive law using SNL. Then now we add and subtract like terms. That's all we have to do. 6x squared minus 12x plus 3x. There's another term. This one minus 2x. Minus 12x plus 3x is negative 9x. Negative 9x minus 2x is minus 11x. And then the constant term is minus 4. We're done. We are done. We are done. I hope you understand why it is that we've done what we've done. Like I said, this was a standalone term. Term 1 minus 2x. Minus, plus and minus separates terms. This is a separate term. So when we FOIL here, we can remove the bracket because there's no relationship of multiplication with this one. But if there was a relation of multiplication, it would be a different story altogether. All right. Please guys, rewind and go back and check the video again if you kind of are lost, right? I don't need to re-explain. You can just go back and listen to it again. I just want to do the same question, just slightly differently. Let's say we had something like this. I'm sure you can see how different this one. How many terms do we have here? Now here we have one term. It's not two terms. Do you see that? It's one term this time around, guys. Even if there was a bracket, and then I said multiply by negative 2x, still it's one term. Okay. Now this one would have a different approach from what we did in the previous example. I hope you guys get the drill. Okay. But I'm not there. I don't want to look at that. Okay. Let's look at this following question here. (3x minus 7x into 2xy plus the 2x cubed). Right, sorry, this is an exponent to the power 3 minus 7y. Again, how many terms do we have here? Okay, hopefully you guys can answer that question. Very nice. So this is negative 7y, by the way. So how many terms? We have 1, and then we have 2. Terms are separated by a plus and a minus sign, but brackets combine terms. So this is one term, this is two terms. According to BODMAS, can we say 3x minus 7x? No, we can't. Why? Because negative 7x is multiplied to this one, so we can't do that. This is a separate term anyway, so 3x is here. All we need to do now is that with this one term, since it's got a monomial by a trinomial, we need to distribute this to the 3 terms. Are you with me? So 3x just stands there. Negative 7x we distribute. By distributing, it allows us to remove the bracket because there's no relationship of multiply with the 3x. Are you with me? So let's do that. Let's distribute using S and L. Remember, negative times a positive, negative. 7 times 2, 14. X times xy, x to the power 2y. Remember, when the bases are the same and we're multiplying, we add the exponents. 1 plus 1, x squared. Y is combined to the x squared. Then negative times positive, negative. 7 times 2, 14. X times x cubed. X to the power 1 plus 3, x to the power 4. Then negative times a negative, positive. 7 times 7, 49. X times y, xy. Then we check, do we have any like terms? 3x, x squared y, no. X4, no. Xy, no. Even though this is xy, this is x and y, but this x has a squared, this one has a to the power 1. Those are unlike terms. So that means we leave the answer like this. Can't go on any further. Okay. We are coming to the end of this very soon. Two over 3 into 6x minus y minus 3 over 2x into 4x minus 4 over 9y. How did he do? Sorry, I forgot there was an x here. So here, how many terms do we have? So once again, we have 1, minus separates the term, and we have 2. So here, once again, distribute for this one term, distribute for this one term. And the distributive law, because terms are separate, distributive law leads to removal of brackets. Do you see that? You see, so if terms are separate, guys, the distributive law leads to a removal of brackets so that we have terms, all right? So how many terms? Like I said, we have 1, minus separates 2, okay? Then that means this we distribute. So sign number letter when you distribute. Remember, positive times positive is positive. 2 over 3 times 6. Okay, so the beauty here is that you can just simply utilize your calculator if you have it. Okay, and I'm just gonna grab it here. so that you don't complicate life. You just 2 over 3. You want to multiply by 6, you get 4. So the number is 4. Are you with me? Yeah. X times x, x to the power 1 plus 1 is x to the power 2. Say 2 over 3 times negative y, positive times the negative is negative. Number 2 over 3, combine the letters x, y. Next, we are done with the first term. Brackets have been removed because this is separate from that. Negative 3 over 2 into 2x, do the same thing. Negative times a positive, negative. Then we go to the number 3 over 2 times 4. If we don't know, 3 over 2 times 4. It's also 6. 6. Then x times x, we have x squared. Then negative times a negative is positive. 3 over 2 times 4 over 9. 3 over 2 times 4 over 9. That gives us 2 over 3. 2 over 3 x, y. Okay. Then we check, do we have any like terms? It seems like we do. So therefore, what's 4x squared minus 6x squared? We know that's negative 2x squared. And then what's negative 2 over 3xy plus 2 over 3xy? That gives us 0. So our answer is negative 2x squared. Okay. We've got one more. This one more is supposed to have been done earlier on, but it's fine. Negative 3 into 2x minus 5, the whole thing squared. So negative 3, this is one term. So if seeing as though it's one term, it means 2x minus 5. We need to open two brackets of 2x minus 5 because those are even unlike terms. So we have to open those brackets. And remember now, because negative 3 has a relationship of this being all one term, negative 3 is multiplied into this. That means when we apply FOIL for this, we do not remove the brackets because there's a negative 3 which has a relationship of multiply with this specific binomial, two binomial brackets. So we can't remove brackets here just yet. So let's do that. Okay, so negative 3 stays, 2x times 2x, 4x squared. 2x times negative 5, negative 10x. Minus 5 times 2x, negative 10x. Negative 5 times negative 5, positive 25. Then like terms inside the bracket, negative 20x plus 25. Then last but not least, we distribute the monomial by the trinomial. Negative 3 times 4x squared is negative 12x squared. Negative 3 times negative 20 is positive 60x. Then negative 3 times 25, that gives us negative 75. Final sweet answer. Right? Guys, that concludes our mission of going through products for now. Obviously, there are more questions that one can do, one can be exposed to, but I think as far as the concept is concerned of products, we have covered the length, breadth, and the scope of what needs to be understood by a learner such as yourself in this grade. Okay, very, very importantly. So please, let's go through them. The next lesson that we'll be doing will be on factorization. So this live lesson will be saved on here. You guys can rewatch it as much as you want. At least it's 1 hour and 10 minutes. I think it's a fruitful 1 hour and 10 minutes. So yeah, please rewatch it as often as you possibly want to so that you can master the concept of products just before we go into factorization. It was great. Thank you so much. Ciao, ciao.